You're listening to Worth Electronics What's Up Radio Podcast, where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and our very own Worth Electronics specialists. We're going to shine a light on interesting topics such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with the Worth Electronics What's Up podcast. In today's podcast, we'll introduce to you the WeFlex and WeFlex High Voltage Transformer series. Now, if you're working on isolated DC to DC converters, then this series could be the one for you. So like the name suggests, Worth Electronics WeFlex, F-L-E-X, are the line of flexible transformers. And today, we're going to give you an overview of the two series, as well as some really important parameters of each one. The WeFlex and WeFlex HV, or high voltage series, are a range of transformers which are all built with 6 independent and identical windings. Both the series consist of 5 different types of transformers, where every type is available with 5 different air gaps. One of the major benefits of the flexible transformer series is that designers can actually connect the windings on a PCB in series or in parallel as you need, meaning that you can configure up to 1,000 different transformers. The transformers are ideal for rapid prototyping, but also for small to medium productions. The WeFlex series provides functional isolation with a withstand voltage of 500 root mean square voltage, or VRMS. For higher isolation test voltages, a customer can use the WeFlex HV series, and this provides an isolation test voltage up to 1.5 kilo VRMS. In order to provide basic insulation instead of functional insulation, the pinout for the types EFD15 and EFD20 are different. Another difference between the WeFlex and the WeFlex HV is the use of the metal clips to provide an even pick-and-place surface. The WeFlex HV transformers provide up to 15% higher saturation currents than their counterparts. Every winding starts on pin 1 to pin 6 side and ends at pin 12 to pin 7 for the WeFlex series, so the winding ends on the opposite side of the bobbin. For the WeFlex HV series, every winding ends on the same side of the bobbin. When an application allows to separate the two sides of the bobbin, the transformer provides basic insulation. All important parameters are defined per the winding. The inductance base is the inductance of each of the 6 windings. Rated current base is also defined per the windings, so driving all windings with this current results in a temperature rise of 40 degrees Celsius. The definition of saturation current is a little more complicated. Saturation current base is defined as the current where inductance drops by 20% when all windings are driven by this current. Of course, saturation current is a matter of the core and not of the winding. So this means current of not used windings can be used for other windings. The same is true for the voltage time product. To calculate the parameters in a given winding configuration, we can use the following formulas. The inductance can be calculated by multiplying inductance base by the square of the number of windings connected in parallel. To calculate the rated current, simply multiply rated current base by the number of windings connected in parallel. Saturation current can be calculated by multiplying saturation current base by 6 and then dividing by the number of windings connected in series. The number of windings in series connected multiplied by the voltage second base results in the voltage time product of the configuration. In summary, the WeFlex and WeFlex HV series of transformers consist of 6 independent windings. These can be connected on the board as required. The transformers facilitate more than 1,000 transformer and choke variants. The transformers still show an outstandingly low level of leakage inductance. Parts without air gap are specifically designed for buck-derived topologies like forward or push-pull converters. The high flexibility of the transformers allowed developers to realize their own transformers without having to resort to a customer-specific transformer. Power levels of between 1 and 50 watts can be transformed with the WeFlex and WeFlex HV series transformers. They can be used at switching frequencies of up to 1 megahertz. You can learn more about the WeFlex and WeFlex HV transformer series at Worth Electronic online. You can complete your design with these transformers that are suitable for all types of isolated DC to DC converters in industrial and telecom applications. Attached images are available in most podcast streaming networks. To view all images, visit www.we-online.com. You're listening to Worth Electronics What's Up radio podcast, where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Worth Electronic technical specialists who are going to shine a light on interesting topics like energy harvesting, wireless power transfer, EMI, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Worth Electronics What's Up podcast.